Good morning once again, and welcome to the Desco Europe webinar on ionisation in electronics assembly. My name is Vaughan Callan. I'm the European Sales Manager for Desco Europe. I'm an ESD certified technician, and I've been in the ESD control industry for over 35 years. And I'll just briefly hand over to Stephen Burns, who can introduce himself.
Thanks, Vaughan. Yeah, good morning, everybody. My name's Stephen Burns, Desco Europe brand manager. I've been with Desco Europe for 12 years now, and I'll be helping to answer any questions that you submit throughout the webinar. So actually, we're going to start today by asking you a question. So up on the screen in just a second, just a question about your experience so far with ionisation. How would you describe your knowledge of ionisation, and some answers to choose from. We're going to leave the poll open for just 1 minute, so please submit your answers there. And as I say, we'll be taking your questions throughout the presentation. In just a second, we'll go back to the presentation, and you'll see on the screen there how to submit your questions, but we really would encourage you to ask any questions you have as we go through. It may be that the questions are answered throughout the presentation, or it may be that we say something you'd like a little more clarification on, or any questions about the standard or the product. Any questions like that. This is our third webinar. We've had some great questions in previous webinars, which have led on to some really interesting discussions by email afterwards. So we'll answer a number of questions throughout the webinar. We'll have a couple of points where we'll stop, take a pause, answer a few of those. We won't get to every single question. Unfortunately, we won't have time, but we will answer every question that's asked by email following the webinar. If you haven't selected your answer yet, please do that, and we'll close the poll in just a couple of seconds. Great, thank you very much. And on the screen there, you can see how you would ask your questions. So depending on which version you're using, it will look either like the image on the left or the right. Just type in your questions there and we'll get to those. Bit of feedback on the poll. So nobody selected I'm an expert. A few people saying that they don't know very much, or they have some basic knowledge. Most people fall in the category of saying that they use ionisers and have some basic knowledge. And that's great, because as we go through the webinar, hopefully there'll be something for everybody, something new that we'll talk to you about, and will expand your understanding and maybe give you some thoughts on how you can use ionisation to improve your ESD control program and better protect the devices you're working with. So Vaughan, back to you.
Okay. Thanks, Stephen. So this is what we'll be looking at this morning. We'll look at understanding ionisation. I'll give you a little bit of how it works, the products and various applications, and we'll also go through the industry requirements for ionisation. So to understand ionisation happens or occurs when high voltage is applied to a sharp point, and this is referred to as high corona discharge. And what it's looking for is in the airflow. You flood the area with positive and negative charged ions. Now, when a static charge is generated, it's because something has become either positively or negatively charged. So whatever that may be it an insulator, something like that, or an isolated conductor, it's become charged up, either has an excess of positive or an excess of negative ions. It doesn't matter whether it's positive or negative, it's still a charge has been generated. So what we're looking to do with ionisation is even that balance out. So therefore, at the whatever's charged up becomes charged negative, because it has an equal number of both positive and negatively charged ions. Now, If we don't use ionisation, neutralisation or the getting rid of the charge occurs naturally. Now, we've all been aware, or most of us will have been aware of, if I move my arrow over to the bottom right-hand corner, where we have rubbed a balloon and then stuck it to the wall. When we've rubbed that balloon, it's taken on an excess charge of either positive or negative, which has enabled it for a period of time to stay, appear to be stuck to the wall. But over time, that balloon will fall because neutralization does occur naturally. The charge will disappear naturally over time, but that process of natural neutralization is much too slow for the protection of ESD susceptible components. And for that reason, and what we're looking at is ionization in electronics assembly, we have to look at ways that we can neutralize charges on insulators and isolated conductors. Now, there's various types of ionization. There's AC, which is alternating current, steady state direct current, and pulse direct current. We use primarily the steady state direct current, although we do have a range of products that also operate in the alternating current sector of ionization. So let's first of all look at alternating current. Now, this dates back to the 1930s, and what this technology does, it relies on a single electrode that rapidly alternates between producing positive and negative ions. It does actually work very well. It always balances, but what it requires is a high speed airflow, because with this technology, as you can see here in the graphic, it's got the emitter pins here along the top, and what it does, it will alternate between producing positive and negative ions. Now, the downside to this is that can result in longer decay times due to ion recombination. Now, what we mean is here, so the emitter pins are sending out negative and positive ions, and what you have is those ions, there is a saying that opposites attract. So, the positive and the negative will attract to each other. Once they do that, they become effectively null and void. So what you have to do is, if we imagine these components down the bottom of this slide here that I'm circling now are is the target area, and something down here could be either positively or negatively charged. What we're relying on is a sufficient number of both positive and negative ions reaching our target area. So if something is positively charged, it will attract the opposite polarity ions to it. Okay, so if it's positively charged, it will attract an equal number of negatively charged ions there, and therefore neutralizing the charge, taking the charge away. Okay, but for alternating current ionization to be effective in doing this, you do need a high speed airflow to get those positive and negative charged ions to the target area before they can recombine and therefore become null and void. Then we look at the steady state direct current ionizers. Now, what these do, the emitter pins simultaneously generate both positive and negative ions, and by doing that, by producing them simultaneously with an airflow, the ion recombination of this type of ionization is minimal. So far more positive and negative ions will reach the target area where we're trying to neutralize the charge, and it has a very fast decay time with low offset voltage. Now, I'll just talk about low offset voltage a little bit. What you will have is, if you are putting an excess of either positive or an excess of negative ions into the area, what you're actually doing excuse me, is you're actually inducing a charge into the area, and that's not really what we want to be doing. And we'll talk about this a bit later during the presentation, that the industry standard calls for an offset voltage of either polarity, either positive or negative, of being less than 35 volts. The steady state DC ionisers do have a very low offset voltage, of which we will show you in a selection charts a little bit later. And these work, unlike the alternating current technology, this works very effectively at much lower airspeed. So you don't need that high airflow to force the ions to the target area, and you can cover a much wider area with this. Whereas if you're looking at the alternating current with a forced air system, that's very much at point of use where you get the ionisation. Whereas in the steady state DC ionisers, you can cover a very much larger area, and you don't get the ion recombination. So as you can see here, down at the target area, we're getting a much better balance of both positive and negative reaching the target area, which is exactly what we want to do, to pick off any imbalance on charged insulator or isolated conductor and neutralize the charge. And now this is the preferred ionization for sensitive devices, and very much the preferred ionization in the electronics manufacturing environment. And then we also have, there is also a pulsed DC, direct current ionization system. And what this does, as you can see here, it will send out, whilst there's two emitter pins here in this graphic, as you'll see, and when it's sending out positive charged ions, the negatively charged emitter pin will be off. So it's as it says, it's pulsing between the two. And what you get with that is longer periods of single polarity ionization, which can result in higher offset voltages. And that is a key, as we'll go through this morning, that the offset voltage mustn't be greater than 35 volts. But this type of ionization does not require airflow, but it does require additional distance to the work surface before, as you can see down here, you're sending out positive, and then over here you're sending out negative. They do need to reach the target area in equal numbers, but so with pulse DC, you do require additional distance to the work surface, but there is the danger of a higher offset voltage. So what we'll do now, I know we're just into the presentation this morning, but we'll take our first break for questions. So I'll hand back to Stephen to see what questions have come in, and he and maybe even myself will answer them for you.
Thanks, Vaughan. Yeah, so thank you very much for your questions. We've had a number. Just to reiterate, we will answer every single question by email. We'll just take a few now, just picking up some that I think will be interesting to lots of people. So there's a question here about whether ionization can be used instead of grounding the work surface in the operator, and we need to say no to that. It's not possible to bypass normal personnel grounding and work surface grounding by using ionisers to neutralize the workbench and the operator. And the reason for that is it's simply too slow. So as Vaughan said earlier, charges that build up on a surface or an object will dissipate naturally over time. That's too slow for ESD control, so we use ionisers to do that. But in terms of people, charges are generated on people all the time, every time they move, and they come into intimate contact with the susceptible device. So the idea of being able to generate a charge on yourself and then pick up a device, ionization is not going to deal with that anywhere near fast enough to provide adequate protection to the device. So it's not a suitable alternative to grounding the work surface and the operator. Grounding is absolutely your first approach, and then ionization, as Vaughan already has mentioned and we'll come back to, is to do with dealing with isolated conductors and insulators. Anything that can be grounded should be grounded. Some terms that we've mentioned a couple of times: offset voltage has come up a lot, and I think we've mentioned balance a couple of times. So the question is, what's the difference between the two? And actually, they're just two terms for the same thing. So whether we refer to offset voltage or balance, we're talking about the same thing, and it's the difference between the number of positive and negative ions being produced. You want that as close to balance as possible to avoid creating a problem, which Vaughan has already mentioned.
Yeah, the European standard we will cover. We'll go into that a little bit more later on and show you the excerpt from the standard. But their recommendation is that the offset voltage, so either an excess of either positive or negative, must be less than 35 volts. And as Stephen said, it's the same terminology. It's different terminology, but the same thing. Balance and offset voltage. It really means exactly as we've just described. Thanks, Stephen.
So a last question for now, before we go back to the webinar. I have a plastic jig on my ESD workbench. Which ioniser would be best suited for my needs, AC, DC, or pulse DC? And we're going to get into applications in just a second. So we've talked about the technology. We're about to get into different types of actual equipment and their usage. One of the controlling factors is not so much what you're trying to neutralize, but what you're trying to protect. So if you have a highly sensitive device on the workbench, really steady state DC, which is going to have the lowest offset voltage of any of the technologies, is the solution that you want to head for. But as Vaughan said, everything is controlled by the standard. So anything that's going to meet the requirements of the standard would be acceptable to the standard. And then it becomes about, do you need something ahead of that, something further than that, depending on the susceptibility of your device. So it's not so much about what you're trying to neutralize as the device you're trying to protect.
Yeah, and ordinarily when we receive an inquiry like that and someone wants to know what is the best ioniser to use in their particular application, well, in normal times, we would arrange to come and visit to look at the actual area that you of concern that you have and make recommendations accordingly. And when normal times return, obviously we'll be doing that, but in the meantime we can do that via video to have a look, or even if you send us photographs, we can maybe give you advice that way also.
Thanks, Vaughan. That's all.
Okay, thanks, Stephen. I'll move on, and thanks for the questions. And as we go through, as we said, please keep the questions coming in, and we'll do our very best to answer them during the webinar. But if we don't get to it, just to reiterate what Stephen said, we will answer every single question back to you via email or even a telephone call. So what we'll do now is we'll look at a few products and their applications, and what we're going to be looking at is our blow-off compressed air guns, which is the alternating current technology, and our ionisers with fans, which is our steady state direct current technology. Now the compressed air or blow-off guns, that works on the alternating current technology, which is a single electrode that alternates very quickly between positive and negative, but it does rely on a high airflow to do that. So these are designed to work with a compressed air line. And what these are used for, as you can see in the graphic on the right hand side, these are very much used for dislodging dust and debris, and therefore, and at the same time of doing that, is it neutralizes the electrostatic charge to prevent further dust and debris attraction onto the surface. So if you look at the photograph on the right hand side over here, this is someone who's working on a mobile phone, and before they're replacing the screen, they're making sure that any debris is dislodged and any charge is neutralized. Now you can dislodge dust and debris using just an air hose with a gun, Okay, that will dislodge it, but what it will actually do, it will actually generate a charge. Charge is generated when two surfaces come into contact with each other. So so in this case, the surface would be the airflow and a compressed air gun hitting the surface of the mobile phone that's being worked upon. And as it makes contact and separates, if it doesn't have an alternating current compressed air ionizer gun on the end of it, you'll actually be inducing a charge. So as you're blowing off the debris, it will blow it off, but it will generate a charge with either excess of positive or negative ions, and that will attract further dust to it. So in that scenario, that is the area where you would want to use a, a blow-off gun attached to a compressed air line. There's various types that we do. This shows you a couple. This one here, for example, has got an ergonomic handle on there for operator comfort. You can see on this top one here, this is operated by a single figure on a trigger, whereas this one spreads that trigger all the way down the handle. So for ergonomics and operator comfort, it's a product that we developed through numerous requests from the customer base that we have to produce an ergonomic handgun. And we also have other handguns, which I will show a little bit later. Oh, sorry, AC compressed air guns, ones that even work with a foot switch, so the operator doesn't have to operate with their hand. It's just a fixed hose that they can then activate the airflow and therefore the ionization with a foot switch. Then we have our overhead and benchtop ionizers, which work on our steady state DC. And as we say, this is the preferred ionization method for general electronics assembly. Now, we've been talking about offset and balance, the same thing. Our ionizers in this particular range, excuse me, have an auto feedback system. So if an ionizer goes out of balance and therefore the offset is not equal, our ionizers will give you both an audible and visual alarm. Okay, so if it starts producing one polarity in greater numbers than the other, it's gone off balance and it's producing a higher offset voltage. It will give you both a visual and audible alarm. If that happens, you need to shut the ionizer down and take remedial action, and that could be cleaning the emitter pins. It could be tweaking it back into. There is a trimming pot on there that you can bring a number of these ionizers back into balance. Okay, so if they go out of balance, we have that, but there is also a number of ionizers in our range that you can use with our static management program, and the static management program will be covered in a future webinar in much more detail. But what this will do, this will continually validate and store the data to show the balance is working and make sure that the decay time is working on it. So it's a continual validation of certain number of ionizers that we manufacture. So ionizers with fans will obviously cover a certain area. Now, if we look at the top right-hand side, we've got one of our 0-volt benchtop ionizers. So the graphic here, this bit here is actually the ionizer, and the optimum area of working where it will be the most effective is roughly around about 40 centimeters by 90 centimeters. That is the optimum area. It will work in all this area, work in a bigger area, but the optimum area for maximum charge dissipation in the fastest time would be in that area of 40 by 90 centimeters. As well as benchtop ionizers, we have our overhead ionizers, and these come in either 2 or 3 fan. And again, what they will do is they have these are suspended above the work area, so you're not taking up any valuable workspace on the working bench area. And these have a larger coverage area. One, they're suspended above the bench area, and 2, there's more fans, either 2 fans or 3 fans against the benchtop ionizers, which have 1. And depending on the number of fans, and the distance that it's set to. Obviously the area is greater that the neutralization of charges occur. And we also even have a small mini fan ionizer for small concentrated areas that can be used on the workbench, but the particular use for this type of ionizer is actually inside your SMT line. So it can actually be very easily placed within the SMT line to neutralize any charges that are being generated inside, for example, a pick and place machine. So I said we'd look at the some ranges of ionizers, and the first one that you can see here is our range of overhead ionizers. And I won't go through all of this. These are all available to you on our website. And at the end of today's webinar, we will be sending out the copy of the presentation that I'm using today, and there is going to be an embedded link in there to take you to these links on our website. But you can see here, this is our range of 2 and 3 fan overhead ionizers, and it tells you, gives you a description. You can see some even come with lights. But the important thing here is, what I'll draw your attention to is the offset voltage. Remember, and I'll be coming back to it when we look at European standards, that the offset voltage must be less than 35 volts, and you can see that all of these are very comfortably in that, and you can see that some of these are even around about the 3 volt, very near to zero offset voltage. And the decay times are, you know, I think the longest on this one is 3.5 seconds, and I'll talk about a decay time in a few minutes. And then we have our range of benchtop ionizers, and once again I'll just draw your attention to the offset voltages, the maximum being 15 volts, well below the 35 volt threshold, and our decay time on our benchtop ionizers, all of them will be 3 seconds or less. And then finally we have our forced air, which is the alternating current ionizers, and I showed you these two over here were earlier in the presentation. This is the one I was referring to. I'm sorry it's a small picture, but when you go onto our website, you can get the full description, a much better graphic of this. But this is one where you would affix this hose to the work surface, and then you would operate it with the foot switch. So instead of moving the gun to the target area, if you was maybe neutralizing a charge on a disassembled mobile phone, you would actually just move the phone or the target area into the fixed airflow area and activate it with a foot switch. And again, we have offset voltages that are below the industry requirements, and again the discharge times are, you can see that even down as low as half a second on this type of technology. So what we'll do now is we'll take another break for questions. So once again, I'll hand you back to Stephen Burns.
Thanks, Vaughan, and we'll start this section of questions again with another poll, which will come up on your screen in just a second. So you'll remember at the beginning we asked for you to just give an indication of your experience with ionizers, how familiar you are, and we've obviously covered a lot of ground since then in terms of the technology, in terms of the different technologies that are available, and then also the different units that we offer, incorporating those different technologies. So just a question to simply ask if there's been anything new in the that you've learned throughout the webinar so far. So while you're answering that question, we'll go through some of the questions that you've submitted. So thank you again for those. So, I mean, this first question, how do I go about working out where in our facility we need ionizers? This is not dissimilar to the question about which ionizer should I use, or at least the answer is pretty similar. And we are going to come on to determining where you need ionizers in a second, but perhaps the easiest way to answer this is to refer back to the survey that Vaughan mentioned earlier on. So in the next section, Vaughan is going to go through what the standard says about the voltage levels that we're looking to protect against from the voltage in the ambient environment through to voltages on products that will likely be on the work surface, different insulators that you need in the work surface, and how you go about identifying which are a danger to your susceptible device or not. And that really controls where you need ionisation. If you don't have high ambient voltage, then you don't need to worry about ionisation. But you, of course, to know that, you have to perform that test. Do you want to say any more on that, Vaughan?
No, I think that covers it. It's just really in normal times, just to reiterate the fact that where do you need ionisers? We appreciate that you're experts in aspects of your job. Our area of expertise is in ESD, and one of the value-added services that we offer is ESD surveys and assessments, where we will come to your facility and look at your ESD handling procedures and products and what you've got, and see if they're compliant with the European standard. And obviously part of that would be, do you need ionisation? And that's what we would look at and be able to advise you accordingly on that. Now that's in more normal times, which we hope will return. But in the just to reiterate once again, if you have a question, then please, or a concern, or where you should have an ioniser, if you should have an ioniser. There's other ways that we can deal with that at this moment in time, and that is to if you could send us a short video, if you can join us on a conference call or a Skype call or something like that, we'll be able to give guidance. And just one other thing I'll add before Stephen goes back to the questions, because we've just been looking at our various ionisers. What we can also do at this time is we can do a virtual demonstration, so via GoToMeeting or a Skype or a Teams meeting in our demo area. We can actually demonstrate to you the different ionisers we have, as well as all the other ESD control products. So if you want a demonstration of an ioniser to help you determine what sort you might need, please drop us a line, because we can do virtual demos for you via the mediums that I just identified. Back to you, Stephen.
Perfect, thank you. So thanks again to the person that asked that question. We will get in touch with you to see exactly how we take that forward, and which of those different ways that Vaughan just mentioned is the best for you to identify where are the areas in your facility that you might need to look at installing ionisation. There's a question here about air guns, so handheld air guns. I use an Ioniser air gun all day, and I find that pressing the button aches my hand. Do you have any alternative solution? So this is not really about ionisation technology, it's more an ergonomic question. And we have a couple of solutions for that. I think it came up already that we have the Viper iron gun, which has a full hand length handle, so, and that obviously spreads the impact of holding the trigger, and is specifically designed ergonomically to reduce the pressure on your hand as you hold the button. Another alternative that we have is a foot switch operated system, and actually the hose itself mounts onto the bench, so it's not handheld at all. So the hose mounts to the bench, it's operated by a foot switch, so it's a fully hands-free operation for that device. So we've got a couple of alternatives there for the person that asked that question. We'll send you links to that when we follow up with you. It's probably worth saying, we're going to follow up with the person that asked the question specifically. If any of the questions that we're answering pique your interest, make you think about that, oh, that's actually something that would be good for me, please do write to us. Either drop a question in the last part of the webinar or write to us afterwards. Vaughan's going to give his contact details right at the end, and do write to us and say, well, that's interesting for me as well. I didn't ask the question, but I'd also like to know about foot operated ionizing air guns as well. That would be great. Last question in this section: how often should you test ionizers? And Vaughan's gone through some of the test equipment already.
No,
Our
I'm coming up to the
ionizers.
test equipment actually.
Oh, sorry, I heard you mention monitoring earlier on.
Yeah, we'll be coming up to the test equipment, but
Okay,
carry on.
so we're about to cover that. But in terms of the frequency of testing, we say that our ionizers should be validated once per year as a minimum. But really, you have to determine for yourself the test frequency that you're going to put in place. So what do I mean by that? Well, different environments are going to have different levels of dust in the atmosphere, and because we're talking about high voltage emitter points, they are going to attract that dust out of the atmosphere, and they are going to affect the performance of the ionizer. So obviously in a dustier atmosphere, your ionizers are going to become less effective more quickly, so you're going to need a shorter cycle of testing and validation. The equipment that we're about to get onto really gives you different ways that you can do that. The fully compliant test that the European standard calls out, a quick test, and then a continuous monitoring solution. But I hope that goes some way to answering the question about how often we require once a year, or we recommend once a year on our equipment. But you really have to make a determination based on your environment. The real issue is your ionizer fixing a problem or creating a problem? You've spent money on an ionizer, it needs to be working. So that's really how it's determined. You need to be making sure that it's within spec. If it's out of spec, it's creating a problem, not fixing one. So that's all the questions for now, Vaughan. I'll hand back to you.
Okay, thanks, Stephen. And again, thanks for the questions. Good questions. So now we'll look at the industry requirements for ionization. An ionizer should be used to neutralize charge on isolated conductors and required insulators, or often referred to as process necessary insulators. And to give a visual of that, what we have here that I'm circling in the bottom right hand corner is we have a printed circuit board full of ESD sensitive components, and right here we have some ribbon cable that is absolutely, right next to sensitive components. Now ribbon cable is going to be of insulative nature, so that would be a process essential insulator. So we need to make sure that we remove charges from that. So these are where we would need to use ionization, is with isolated conductors and required insulators. Now, the industry standard, that is the reference is on the screen. I won't read out all the numbers for you because you won't remember them anyway, but you can see it here. And as I say, we are going to be sending you a copy of this presentation. But there are two requirements for ionization, and they are for product qualification and compliance verification. So product qualification is when you're looking to specify what ionizer that you use, and when specifying the ionizer that you use, they must be able to decay a charge of 1,000 volts to 100 volts or less, and that be either positive or negative voltage in less than 20 seconds. And it must have an offset voltage of less than 35 volts. And then for the other requirement is for compliance verification. So when an ionizer is in situ, again, it must be able to decay a charge of 1,000 volts, either positive or negative, in from 1,000 to less than 100 volts in less than 20 seconds, or user defined. Generally, most companies will have a definition of less than 20 seconds. A static event happens in much less than 20 seconds. So what you're actually looking for is to get that decay time to as close to 0 seconds as you can possibly get. And again, for the compliance verification, again, the offset voltage must not be greater than 35 volts, either positive or negative. So going back to the question that was asked and what Stephen was referring to, the standard calls for a full verification annually, and to do that you would need to use a charge plate monitor, and that will check for decay times and offset voltages, and that's the annual verification of which a record needs to be kept. But certainly, a year between verification is a long time. So what we recommend and what you is that you use an ionization test kit, which is a quick test that tests for decay time, decay speed, and offset voltage. And what you would do with using this, and you would just put a known charge from the charging box here onto the field meter with attachment, and you would put a known charge both positive and then a known charge negative, and you measure the decay time on that. That should be done monthly or even more frequently than that, because as Stephen said, and we've been going through in the presentation, if an ionizer is producing more positive than the negative, you're actually inducing a charge onto the work area. And these ionizers, the direct current ionizers, the industry standard ionizer, rely on the sharp emitter pins, as I referred to at the very beginning, the high corona discharge pins, and all areas, and some more so than others, they have dust, and because of the high voltage in the sharp point, it attracts dust and debris to the emitter pin, and as that builds up, that will affect the output of the ionizer. So if the negatively charged emitter pins had more fuzz on them than the positively charged emitter pins, that's when it would go out of balance. So a regular check of by using an ionization test kit throughout the year, at much more frequent periods, will ensure that you know that your ionizer is performing, and therefore if it's not, you can take remedial action. And then we also have here, as part of our static management program, we have an ionizer monitoring system that will continually monitor it. So it's not annual, it's not at defined periods, it's continually monitoring the performance of the ionizer for decay time and offset voltage. And the report, and it's sending back the information into the data acquisition system in the static management program. So those are for critical areas where you need to ensure that that the ionizer is performing correctly. Then there is also the option of monitoring it continuously. So before we deal with specific items that might carry a charge, first of all, we need to make sure that the environment doesn't have high static voltage. Now, this is especially possible in environments that are controlled to a low humidity. Most places will now be air conditioned, and therefore the humidity is very low. So we need to make sure of that in the first instance. Then the industry calls out the 30 centimeter roll. So if a process essential insulator has voltage on it of excess of 2000 volts, that process essential insulator needs to be kept to a minimum of 30 centimeters away from any static sensitive devices, or if possible, change it to that process essential insulator, change it to an ESD safe version. But if that's not possible, then you would need to use an ionizer to neutralize the charge on that insulator. And furthermore, the industry calls out the 2.5 centimeter rule. And again, if a process essential insulator comes within 2.5 centimeters of a static sensitive device and has a voltage in excess of 125 volts, then that charge will need to be neutralized. And I did ask you to keep the visual in mind of that printed circuit board with the ribbon cable, where you can see that that one would most certainly fall within the 2.5 centimeter rule. And ribbon cable, and most insulators can easily have charges in excess of 125 volts. So that is where you would need to use an ionizer to neutralize any charges. And then we have isolated conductors. Now, if an isolator isolated conductor comes in contact with a static sensitive device, what you could have is a charge device model. So if it can't be, if that isolated conductor cannot be grounded or it could potentially bonded together, then again, if the voltage on that isolated conductor is greater than 35 volts, then once again you would need to use an ionizer to neutralize any charges. So we're very near the end, so we'll take our final break for questions, and once again I'll hand you back to Stephen Burns.
Thanks, Vaughan. Yeah, a few more questions we'll cover before the end. We'll try and do that quite quickly because we're running short of time. I realised I didn't give the results of the previous poll. Just to say everybody who responded said that they had learned something new during the course of the webinar, which is great. It would be great to hear from you, particularly about what you learned, what was the new thing, and if you have any follow-up questions on that, we'd be delighted to take that discussion forward. We do have one last poll, which I'll set running now. And this is, one second. Actually, this poll has not been set up correctly, so we won't launch that. In fact, the question that we were going to ask was to do with any changes that you make. Given that everybody responded saying that they've learned something new, I wonder if that new information that you've received today is going to lead to some changes in how you approach ionization and neutralization of insulators within your environment. So it would be great to hear from you, particularly on that. Do write to us. We're going to be following up with everybody, whether you asked a question or not, to thank you for coming to the webinar and to introduce an offer to you. And it would be great to hear from you about the thing that you learned and whether it's going to make a change in your environment. And of course, Vaughan already mentioned that we've got the online virtual demonstration possibility that we can set up with you if you want to discuss exactly what changes you're looking to make. That would be great. As I said, we'll go quite quickly through these questions. We've actually got three that kind of work quite closely together. One is, can you continuously monitor ionizers, which we've discussed very briefly. We'll go into a bit more on that. And the next two are kind of similar. How do you know if ionizers are working, and do you have an ionizer that the employee can't turn off? Now, just that last one very quickly, we do have ionizers which is switched on and off by a key, which you can then remove. However, that it's still a mains powered device, so the operator could switch it off at the mains. The continuous monitoring solution that Vaughan mentioned earlier, the EM Aware connected to SMP, the static management program, that's obviously going to tell you if the ionizer has been switched off. It's performing two tests. One is the offset voltage or balance test to make sure that the ionizer is within balance, but also every 4 minutes or so, it's performing a decay time test. Now, it may be that when you switch an ionizer off, the environment stays in balance, but it will fail that decay time test if it's been switched off by the operator. So you will know if the ionizer that you spent money on has been switched off at the workbench if you employ that continuous monitoring solution. And the question about if an ionizer is working, that could mean various things. It could mean, is it switched on? It could mean, has it gone out of balance? It could mean, is the decay time not in spec? Well, actually, the EM Aware is going to tell you all of those things. So 3 questions in one there. The last question is a type of ionizer, which is the best type of ionizer for use in my SMT line. We do have a couple of ionizers, small ionizers that are specifically designed to be mounted inside machines. They are small, they're lightweight, so they're easy to mount safely, not likely to fall off, and that's exactly what they've been designed for mounting inside those machines. So the person who asked that question will send a link to you.
Yeah, and that's one of the areas that where we would be very happy to come and visit and carry out an ESD assessment, where we can actually place a sensor inside your SMT line at various points to determine the best to determine if there are ESD events, and to determine if and where an ionizer should be placed within the line.
Perfect. A couple more questions just come in, which I'd love to answer. Sorry for taking a little more time. There's a question about our local dealer, who's the local dealer in our area. So we'll send a link to you with details for our distributor in your area. And next question, do you have an ioniser that can be activated by a relay? And the answer today is no. We have just released one in North America, and we're looking for a CE solution for that, and a UK and European compatible solution for that at the moment. So it's actually already on the table with our R&D team. It's been released for North America. We need to look for a European and approved version. The way it works is that in fact it's a power strip that is relay controlled. So the idea is that until you have connected your wrist strap, the bench won't electrify. So you can imagine all of the things that you require to be switched on: your ioniser, your lights, your soldering iron, your fume extraction. All of that would be connected to the power strip, and then the power strip is only activated once the wrist strap is connected. It's that type of a solution. So we'll send you more details on that, but just to note that it's currently in development for Europe. We're doing research as to putting that in play.
Yeah, as Stephen said, it exists, but before we can launch that into the European market, we have to go through the CE approval process, which is something that we're endeavouring to do at this time. So basically watch this space, and as soon as it's available, we will be doing a product launch on that. Thanks.
That's all the questions we're going to cover during the webinar, Vaughan. We'll follow up with everybody who's asked a question that we haven't answered by email and get back to you.
Okay, thanks, Stephen. Thanks. So yeah, that's it, guys. So I just want to, in closing, just you'll see on the screen there, my contact details are there. So if you have any questions that you weren't able to type into the question excuse me, section of the webinar, or it's more detailed, then please drop me an email, and we will be answering your question. You'll know that I refer to the European standard and the requirements of that. Well, in the PowerPoint here, there is an embedded link to the IEC website where you can purchase and download the relevant standards, and also a link to our website, which you probably all know, but please use all the resources on our website. There's a lot more information on ionisation, and every one of our products, and as we're talking about ionisation today, every one of our ionisers has a full technical bulletin that will certainly help you determine in conjunction with talking to ourselves, which would be the right ioniser for yourself. And you know, we welcome if there's any feedback on these webinars, if there is any improvements you'd like to see, or just any feedback, either good, bad, or indifferent, you know, please feel free to share it with us. And in closing, just finally, thank you very much for your time this morning, and look out for the next invite. We do have another webinar next week. I think it's on wrist straps, I believe, but please, we encourage you to sign up to that, because hey, we all know a little, but sometimes it's better to accept that we can still learn something as we go through. So thank you very much for your time, and I wish you all a good day. Thank you.